In JavaScript, data can be retrieved in 4 different ways. This video, I'll talk about 2 different questions that you can ask yourself when dealing with data. Who has the initiative, the call side or the implementation? Is the data single value or multiple values? Asking these 2 questions will point you in the right direction of which data structures and data delivery methods you should use. In an effort to distill both synchronous and asynchronous code into a simple model, the people behind RxJS have come up with the general theory of reactivity. It's this model. It uses lots of fancy sciencey words like spatial and temporal, singular and plural versus single value and multiple values and synchronous code and asynchronous code. So I've simplified the model. The model says when dealing with a single value that is synchronous, you can use any data structure that is returned from a function. When working with multiple values that is synchronous, you can use an array, a set, a map, an object, anything that is a container type that can store multiple things that you have available right now. When working with push data, so asynchronous data, you can use a promise and an observable when it's single and multiple values. A function allows delivering a single value when you call it. A promise allows delivering a single value at a later point in time. An iterator allows delivering multiple values when you request it. And an observable allows delivering multiple values at a later point in time. Now these are specific names for JavaScript, but this general theory applies to all programming languages out there. My examples just happen to be in JavaScript. I'll talk about all 4 of these options, so it becomes crystal clear for you when you have to solve your programming problem what data delivery method you should pick. Let's get into it. First, let's talk about a function. A function allows delivery of a single value when it's called. This is a pool model. There's a producer and a consumer of data. The producer, the implementation of the function, cannot push data onto the call side. The initiative, instead, lies with the call side. The call side, the thing, the piece of code that is calling the function, has the initiative. It determines, now I want its value, so now I'm going to call the function. The producer, therefore, is passive. It produces data when it is called, and the call side, the consumer, is active. It decides when the data is requested. Let's look at an example. In here you see the range function that I've used before. It is a recursive function. You give it a min-max and it needs an accumulator because it's a recursive function. The call side is the thing that has the initiative. This is the most simple example in this model. Again, the theoretical model is beautiful because it is simple. It specifies very little things. This is the most basic example there is. The range function by itself doesn't do anything. When you call it, when you tell it what to do, it will start producing data. The result it produces in this case is an array with the numbers right now. It doesn't matter what it is actually producing. The fact is it could produce a single value as well. Next, promises. A promise allows delivery of a single value at a later point in time. Promises uses a push model. The producer of data in this case is active. It decides when the data becomes available. The initiative of when the data is available is with the producer. The consumer in this sense is passive. It has to be reactive. It has to react whenever the data is available, then it can run some code. It cannot demand the data right now. It has to wait until it becomes available. This is asynchronous code. This is also called the observer pattern or the event emitter. A promise therefore represents a value in the future. It is a contract that at some point in time you will get a value. It has 3 distinct states. It can be pending when it is still not settled, and then it can be either resolved or rejected. I will not go into too much details here because this video would become way too long, but let's look at a few. I've got another producer and consumer, the call side again. And this timeout promise will resolve when the timeout is passed. It uses the set timeout, which takes a callback. And callbacks are the first basic atom that you need to form any asynchronous code in JavaScript. A function will be called when it is available. A promise is a function that you can call. You can construct this new class in JavaScript that takes a function that is resolve and reject arguments. These arguments are functions on themselves that you can call whenever it is resolved or rejected. If reject is simply the word for I failed to produce this, here is an error instead of the value that I have promised you. The resolve in this case is called by the setTimeout, which just takes a function, a callback function, and runs it after the milliseconds have passed. Using a promise is calling the function and then the then method to catch a error. If it is instead rejected, you would have a catch method that is called on this again. This would be another function that is only ran when the promise is rejected. Again, I will not go into too much details here. Nowadays we have nicer syntax for this. We have the async await syntax, which is really just the same thing. It's syntactic sugar for promises. If you have an async function that does an await, this really is just written down in Babel literally, but also in the V8 engine, for example, it is turned into a promise. This function that has async await just returns a promise. If you were to use it from a promise context, this is all fine. You can mix promises and async await code. Next, the iterator. An iterator allows delivery of multiple values when requested. It is synchronous. And this is the pull model again. The initiative lies with the call side, with the consumer of the data. I want data right now. I will call the iterator, request the next piece of data, and I will retrieve this piece of data. The producer of data is passive. It cannot decide when to produce data. It has to produce data when data is requested. It can produce multiple pieces of data. That is what an iterator is different from a function that produces a single value. An iterator is, of course, famously the array or a set or a map or anything like this. ECMAScript defines two iteration protocols. Iterable is a data structure that contains the elements you want to iterate. And I have an example in a bit. And there's also the Iterator protocol, which is a pointer, like a database pointer. It is the state of where the iteration is right now. It doesn't contain data itself, it is just the state. It implements a next method and it has a done and value property. And the iterable is implementing a function, the symbol iterator function, that returns an object conforming to the iterator protocol. And good to note, the first sentence here, they aren't built-ins for syntax, they're protocols. You can implement an iterator on any object if you want. You just have to abide by the convention, which is naming your things in a certain way, making a function that has this symbol as its key, and then returning an object with the next property, and then you will be able to use your iterable object on a for off or on built-ins like the 3-dot destructor. Let's look at an example. In here I've got another range function, but this produces data when requested. It is called lazy because it will only produce new data when you call the next function and then access its value. It is not going to produce data like the previous range function we saw, which you have to give up I want from here to there, and if you say I want from 0 to 100, it will just spit out 100 different numbers for you. And it has these at the same time immediately available. It will require 100 entries of memory and everything is there at an instant. With an iterator, you can generate data at a later point in time. It is not asynchronous in the sense that you immediately get data, you demand data right now as the consumer and you immediately get it. The iterator has to give you the data. The iterator has to produce this data for you. So it is not asynchronous code, but it is multiple pieces of data that you can generate at will. So you can have infinite iterators, for example. This is a range function that goes all the way to infinity. So implementing an iterator is pretty simple. You have to return an object that has a next property. In this case, I've only implemented the iterator protocol and not the iterable protocol, because the iterable is for data structures that contain data that you want to be iterable. And this isn't a data structure. This is a function that can generate infinite amounts of data. So it's okay to have an iterator in this case. You cannot put this in a for of loop. You would have to call it somehow differently because the for of loop would run out of memory. You cannot run this code infinitely. Let's look at a different example. I have In a previous video of mine on recursion, I've created this tree data structure that is a nested data structure. It's recursive. You can create these instances and you give them multiple children if you want. To be able to traverse this, I've implemented a map in the past, a map function that is recursive. It functions like the array map. You give it a function and it returns it calls for every node in the tree in this case, instead of in the array. It calls the function, you supply it, and then returns a new data structure with the new values of what your function has returned. Now I've also implemented the Iterator and Iterable protocols by defining a function with this name, the symbol Iterator, which is what the protocol is about. I've implemented this fairly simple with just accessing my map, because I already have written the iteration code, the code to traverse the tree, to walk it, and to then create new trees and call the recursive map again. That I'm just reusing my own map here, but I'm creating this list and I am having my pointer here that allows the iteration of the data structure. So again, there's an object here. The Iterator protocol is returning an object with a next method, and the values you return are objects with done, true or false, and otherwise an object with a value and then done, false. So the moment you don't have a value anymore, you would give it a return value of done, true, and the moment you would have a value, you would give it done, false. So this is a way to implement the iteration protocols on an existing data structure. I have already adhered to the interface of map, which is a nice interface to adhere to at the same time, but now I can use my tree data structure with a for-of construct. I could also, with versions, I could cast it to an array by doing this kind of thing, and this means I can use my recursive data structure now in the for-of loop, which is a nice way to access this data. And for-of looks for the iterable protocols. It tries to call this symbol iterator method, see if it works, and then if it retrieves an object with next methods, then it will succeed. It will try and call this again and again. And this also works with asynchronous code, but that's generators and that's outside of scope for this video. Again, strings, arrays, and also there's typed arrays, maps, sets, they're all built-in iterables, and all of these would work with for-of statements. And there's the spread syntax, the array destructuring, all these features expect iterables. So you can use this for many different things in the language since 6, where I think it was introduced. And lastly, the observable. Observables allow delivery of multiple values at different points in time. They are the push model. The producer has the initiative. It produces data at its own pace. It determines, now I have new data available, I will push it towards the consumer. The consumer has to deal with it. The consumer does not have the initiative. It will have to react. It is passive. They're also called streams. An implementation in Node.js is called streams. Let's look at an example. In here I'm importing the observable from RxJS, but there's multiple observable implementations out there. And if you're in Node, then you have the streams library you could use. The observable is you need to instantiate a class here, and you will then be able to push new data to it. It could be any data. It could be events that just have a name and no data. It could be large data structures. It doesn't really matter. These right now are all pushing synchronous events to it, but there's a set timeout. This is a school textbook example that at some point in time you get a fourth event in here, and you don't know when this will be, but all these events could be asynchronous. These could be mouse clicks that the user is doing across the website that you're all receiving as different events. It could literally be anything. And the consumer, the call side, doesn't make any difference in how they're using this right now. This is literally, I have a event that is being called, a function that is being called, and I receive data and I can handle this data. And this observable needs to be subscribed. Events need to be subscribed to. And right now this doesn't look like much because this is a very simple example, but the beauty about observables is that, and this is especially true for the RxJS implementation, it allows data to be handled as if it were synchronous. There's no difference in what the code looks like. I have two examples here that they're basically the same code, but one is data that just comes from local memory. It is available right now. It is an iterator. There's no asynchronicity going on here. And the other one is data from the network, which has to be asynchronous somehow. This could be push events that the server is pushing. And they are both filtering, mapping, and in this case subscribing, and the other one is calling a for each. These filter and map implementation in the iteration example, in the synchronous example, are the filter and map methods of JavaScript, of the array prototype. But these, because this is returning an observable, these are the filter and map implementation of the RxJS framework, which is a different implementation because this code is actually asynchronous in this case, which is also why you need to call the subscribe method at the end instead of the for each. This is valuable in some way, but it can also be confusing. It is, however, the same thing that async and await keywords are trying to achieve in the JavaScript language. You used to have a promise, now you have the async await syntactic sugar. Suddenly you can use a try-catch around asynchronous code that used to not be possible. Right now it is possible. The code looks almost the same, you only see the difference with the async and await keywords. This is async code. It is known, therefore, but with this it is harder to see. Can be a disadvantage, can be an advantage. It is definitely a lot simpler than the textbook example I gave here. This is not how you would usually call these things yourself. This is how you would use it with a library. To summarize, we looked at functions, promises, iterators, and observables. They're all useful in their own way. They're different, and it's good to start asking yourself these questions. Hey, where do I need to use which one? What kind of data am I dealing with? Is question one. And question two is, what is the data retrieval method? Is it instant? Where is the initiative? Where is this a pull or a push model? When you start in your career, you're probably thinking of values and functions and promises first, and then later on you'll move to iterators or observables. They're definitely less known, but I think they're highly useful and underrated, highly underrated. So it's my recommendation to also deep dive into them at some point. Don't implement your own promise, don't implement your own observable. Promises are in the language and observables are more complex than you think, so you probably want to use a library like RxJS out there. And one last tip, iterators are very nice to work with from a consumer perspective. If you are the call side, if you are consuming the iteration protocols, then writing this for-of syntax or being able to destructure this into an array or cast it into an array or somehow work with all this syntax that was introduced with ECMAScript 6. This is really a nice way to work. You probably want to design your interfaces so that your consumer has this nicer interface to work with. And that's it. I hope you've enjoyed this. I hope this was helpful in some way. If you have any questions or requests for things you'd like to see, if you have any ideas, please let me know in the comments and subscribe. Thank you very much for watching.